Hey everyone, can you hear me okay from here? All right. Like Hamilton explained, I'm doing a brief synopsis on Actor Framework, but mostly what I want to talk about is what's called a network endpoint actor. It's a package that you can install through VIDM that works with the base Actor Framework library. But to begin with, to start with, we have the Actor Framework as itself. It's a form of object-oriented programming that you also learn on. And we want to isolate it to a single thread,
a separate process that can run independently. That's what we call an actor. In which, if you have the handbook or you get to do the Actor Framework class, it'll go into further detail, calling it AOP instead of OOP, actor-oriented programming. But with the base library, we have quite a few functions to work with, launching actors and sending base messages. This is just a brief palette. I'll go over a few of them in later slides. But in order to actually program with Actor Framework, we need three specific components. We need an actor, a message, and an address. The actor is, what was explained previously, the combination of three aspects: independent thread, a function, and its data. The message itself is any form of process, any form of information you want to use that can be sent to an actor to tell it to perform the function. Depending on what LabVIEW version you use, if you're using older versions like LabVIEW 2018 or later, you have to use something what's called an abstract message. I don't go into detail with it here, but it's an older form of messaging. But now we have newer forms such as interfaces. And then the address is the destination of how you send the message, whether that be something like a queue, an event, a user event, any other form of communication you want to use, even just like a Boolean. However, for us, we typically use the built-in form of communication for Actor Framework, which is itself and queuer for queued message handler. And all actors, as soon as you launch them using that launch root actor VI, it will create its own enqueuer reference that you would use to send messages with. And this will allow the actor itself to run independently from the main application. All you need to use is the actual enqueuer reference itself in the main application to communicate with the actor. Here, once you create the actor itself using Actor Framework, it has built-in core VIs that technically get made alongside itself, but you don't actually ever really see them. They run using just the Actor Framework library that you inherit from. However, you can override them to do certain actions that you would like to use. The main four are the ones I have listed here. Typically, these are the only ones you would ever really need to override. There are very few cases where you may want to override even further VIs, but I don't go into them here. The pre-launch init, this is any sort of initialized VI you typically run with any other application. Anything with a config file, references for user events, queues, whatever this actor is going to use, you want to initialize it here in this VI. And here we may also send a message to any sort of a higher up VI or actor saying we initialized correctly or we failed to initialize correctly, send some sort of error message. The actor core itself, that's your main loop, your main VI, the main code of the actual actor itself. Typically, this would be a while loop with an event structure inside of it. If you want to use user events, or if you have an actual GUI interface with your actor, if you do any sort of Boolean presses, number changes, anything like that, your plan is to just have this run consistently with whatever your independent application is until you're ready to shut down the whole application. When you're ready to shut down the whole application, that's what we use our stop core for. If you leave it alone, all it will do is just attempt to close itself, stop. It won't stop any while loops you create, so you do need to override if you attempt to override the actor core. Make sure you can actually destroy any references, any loops that you try to create in your actor core for it to shut down cleanly. If not, it will lock up your project. It will also, as I put in here, if you have multiple actors, say it calls another actor below itself, it will automatically send the same stop message to its nested actor. And in the previous palette that I showed, there's 3 different options for the stop. We have normal, emergency, or the option to send either or. Just like with queued message handler, you can set priority to your message. And this is what allows you to send the either high priority or normal priority for your stop message. And then one that typically I don't override as much, but it is an important one to override if you need it, is to handle error. Say you have special error codes that you put into your project that you want to be able to log something or submit an error back to another application you have running on another computer. You would want to override this to handle any and all errors that you actually experience inside the actor. Here, when you want to use the actors in your project, the first one you would have run by launched by either a top-level VI or just any other rough term, but regular VI, non-object-oriented, non-actor VI in your program using what was the launch root actor function I had a screenshot of earlier. Once that actor is launched, you can launch more in the future using a new function called launch nested actor VI. Has the same exact functionality as the root actor, but it has an additional data tunnel for the calling actor. If you were to use the launch nested actor, we have what's in this picture here, a actor tree. It would show up directly under it, a straight line down, or if it branches off into multiple nested actors, you'd see multiple branches being formed. But the start of your actor tree will always be whatever is called by the launch root actor. And then right above it, it's going to always be the actor framework library itself. That's this actor framework class in the middle there. Now, for anything you do in your actor core, whatever method you're going to use to actually go through your event structure, your while loop, what have you, you're going to need to do something similar to sending a message to that actor. I like to use the queued actual message and queuer built in with Actor Framework. And so an easy way that LabVIEW has created for you to do this is create your own VI, separate VI, no override. And this would be your method, your function that you want it to perform based on getting this message. Whenever you create that, you have an option right-clicking on that VI inside the Project Explorer. And Actor Framework will give you the option of creating a message. And you also see in the picture, you can use it to also create an abstract message. However, if you're using like latest LabVIEW or pretty recent LabVIEW, I wouldn't recommend abstract messages. This will automatically create this class that, this is actually blocking a little bit, I'm sorry about that. It'll automatically create this message class in your project. It'll be in a new virtual folder created for your actor called messages for this actor. And it'll also automatically create those 3 files under the LabVIEW class, the private data control, the send VI, and the do VI. The send VI and the do VI is what's going to handle everything for commanding your actor. The send VI is the actual message itself that you're going to enqueue to your actor. Say you want your actor to record current temperature or like check thermostat. What your side application would do is enqueue using the actor's built-in incure reference. This send VI, send record temperature VI, and it would allow the actor core to call upon the do VI. The do VI is actually telling it, run this method, run the new VI that you just created. And this allows you to be able to separate the two entities from each other, have them be in two instances. That was a very brief crash course on Actor Framework, but that little bit there is really what was necessary in order to learn or know what I did for this new package that has been worked on pretty recently called network endpoint actors. The main purpose of them is if we want to be able to communicate not only from separate applications, but also from separate machines entirely, separate targets entirely. And this will allow us to use any sort of protocol that we would want to actually communicate our message over. Built in, NI supplies you to use TCP/IP or network streams. In my case, I use TCP. But the documentation supports that you can create your own protocol or develop your own protocol to use with the endpoint actors. Your only requirement is you need it to be able to create that as an object itself for the built-in library to accept it. And here's a brief palette. I'm going to go over a few of the VIs in here that you see in the following slides. Inside here, this is this palette you see here is under the protocols folder of this palette. And this is what you need to use to create your protocol that you want to use for your network endpoint actor. Here for the more information I have is for the TCP protocol, as that's what I used in my own development. And for the TCP, you need to have your initiator and listener. Initiator, you would want to create on whatever your local machine is going to be, and the listener would be for the remote. And then the write local IP address and write flattener, that's additional data you can write into the data of what's called the message stream that will accept whatever protocol you wish to use. Flattener, as I write here, it's not required. Unfortunately, I actually don't know much of what it does. I didn't get to work with it as much, but from what I gathered, it's similar to how when you normally do your messaging, you can choose, you can create your own method of encryption if you need to, but network endpoints already has its own form of encryption. This could allow you to change how you want to do it. Say you don't want to flatten it to a string, you want to do something else, you can use this flattener VI. But what you actually have to use is the local IP address, because you need to have a remote IP address and whatever port you want to use to create the TCP connection. The network stream, similar aspect, its two required tunnels are its remote address and name as strings. And then from there, you just have to do the initiator, also on local side, listener on the remote side. But for that one, I don't have as much experience in. If you have questions about that, I'll be more than happy to tinker around with it myself and get back to you with it. And once you determine what protocol you want to use, you would go back to the high point, the top level point of this palette, and you'd have this write message stream, write timeout. This is for the actual class you're working under called endpoint, network endpoint. And you are writing this new data into that class, being the message stream, which is whatever protocol you decide to use, and then your timeout. What it uses in its library is, for timeout, it doesn't specify a timeout for the connection being created and a timeout for the message being sent or received. It just uses that same value for both. So that's one problem you would have to consider, determining what your timeout would want to be for both applications. And then similar to the actual functions you'd see in the base LabVIEW palette for wanting to send a message through queued message handler or UDP, TCP, the timeout values in milliseconds. Now, once you have filled in all that data, you can now choose to create whatever endpoint actor you want to use. There are two different types. Here, it's the nested endpoint, and the next slide will discuss the caller endpoint actor. The nested endpoint is being launched by some sort of root actor, some calling actor, and its only goal is to be served as one side of the network connection. It will only forward it'll forward messages back to its caller, or it'll push messages through whatever protocol you chose to the other side of the network. Other than that, it doesn't do any sort of higher activity. And as an example here, this gray dotted line is the network connection, showing they're two separate machines. Whatever your caller A VI, if it were to launch a nested endpoint, nested A, and whatever your other application on another machine is, it would launch a nested B. If both of those are nested endpoint actors with the same port and IP information, they will become a pair with each other, in which their only goal is to send messages, whether it be user events or whatever you determine beforehand your application, sends it back and forth between each other. The other one is the caller endpoint actor. It's similar to how the nested endpoint works, except now the caller is higher up on the tree for the whatever side you choose to have a caller endpoint. The difference in functionality is whatever that the nested actor is for the caller endpoint actor, it functionally becomes a new nested actor for the other side of the application, the new application. So for here in this picture, how we have a caller B, caller actor B launches nested actor B, that is a nested endpoint actor. And on application A, we have a calling actor A that has a caller endpoint instead of using a nested endpoint. They form the pair connection between each other over the TCP or network stream, whatever protocol you choose to use. And then if any message gets sent across the network to, say, the caller A, it's acting as if it's sending a message all the way to nested A. This allows it to where I didn't use this one as much. I preferred the nested endpoint actor, mostly because I liked having two main performing actors on both applications instead of having one like high performing actor's only goal being to see a message and send it somewhere. But I'm pretty sure with the example I made, it can work either way. But for my programming understanding, I prefer the nested over the calling, because all that really happens here is the nested actor of A just becomes a brand new nested actor for B, as if like the actor tree gets squished with each other. These are some benefits, some pros and cons I discovered when I was working on my project. I like it because you're able to consolidate your code. You can choose to have what projects you build. You can have it really only handle the code of whatever its side of the network needs to handle. Say you have one side be a GUI and the other side be your thermostat or whatever function you need to do, main tool. You can have your project A just be the GUI itself and nothing else, and its nested endpoint, or whatever endpoint actor you choose to use. And then on the other side of the application, it will just be its nested endpoint or whatever endpoint actor and its actual forming code. And with this, Actor Framework allows huge scalability due to them being able to run as independent threads, independent instances of each other. You can use this to create multiple endpoint actors to hit multiple remote systems. Example of this, I can't go into too much detail as it's work related, but that's what inspired me to learn a bit more about this package. Is we're able to send a message telling do the same function across 5 different computers at once using the scalability of Actor Framework. The only real restriction is the communication that it supports natively. We don't have stuff like UDP or serial. You're forced to use TCP, IP, or network streams, which for me is just TCP because I don't have a huge understanding on how network streams work. And if, depending on how you're doing your coding, you still do have to duplicate it, just not as much as it would be if you had it as 2 main applications running using, say, UDP on the same computer. That's more so, you're going to see that in my project, because I was kind of discovering what should be a good practice for how to develop it as I was working on it myself. And I unfortunately duplicated a lot more code than I would have to if I was able to do it over again. But that's my brief explanation over Actor Framework and network endpoints. If anyone has any questions, or I'll go straight into my project. Okay. So here I've created 2 projects. The local, what's going to be my local project is the remote target status tool project. And the remote side is the remote target resource tool. As I said before, I didn't do as good of a job as I wanted to in terms of coding practice. So the only difference you're going to see between these 2 projects is the launcher VI. My local launcher here, its only goal is to launch the GUI, what's actually going to run on whatever your local machine is going to be. It'll launch that actor and its nested actors and nothing else. It won't touch the actual remote actor I have created here. Inversely, the remote side of my program only launches the remote actor that I've created and doesn't touch the GUI actor at all. But with how I set up my messages, it needs to know both actors exist, both classes exist, to actually get the messages sent across. I would need to go in and kind of change my my coding setup to where the network endpoints were actually completely independent of each other. They wouldn't need to know what data existed between the 2 to actually send the messages over correctly. But here, first we can start with the GUI class. And here, the only ones I overwrote was the pre-launch, the actor core, and the stop core. This parse data VI is a brand new one that I created independent of an override. And that's what is actually created as a message for this actor. Okay. That's apologies for that. I'm not sure why it won't show the front panel. It's somewhere on the computer. But this is my main actor core for the GUI actor. This is what you're really ever going to see. And here it's just a while loop with a event structure in it for user events I created. Its only goal really is I'm wanting to send a message for refreshing data. And then we just wait on an infinite timeout based on if I want to keep refreshing my data, say 5 minutes later, I can hit the button again and it'll send the same message. Or I just want to stop all my actors, in which it will follow my stop event. And then likewise, whenever it receives a new event, it can I have it receiving a message based on what the network endpoint actor comes back with. Any new info, say once the refresh message gets sent, its only goal is to wait until this new user event gets triggered, called update data, where I grab everything that I just got from the remote side and parse it unfortunately, I would show it, but I don't know why my front panel won't show up. Once I run it, it should pop up in the middle of my computer, and then you'd be able to see what the actual GUI looks like.
Are you used to looking at monitors? Is that on your second monitor?
That may be what's going on. Yeah.
We're up against a new control
T? Oh, it's real. It's alive. So this is what the actual GUIs looks like. This is what only what the local machine would see in the final result of my project. Here we can also look at the pre-launch here, which what I'm grabbing here is only user events is what I've had to initialize, or what I had to create. I didn't need to use any other forms of communication or configuration information in this class. So in my override, the only thing that's happening here is creating user events and putting it into the class's data. And likewise for stop core, for uninitializing all of my references and data, we're just destroying the events here. Now we can go into the new function that I made specifically for the GUI class, the parse data. It grabs an array, a string array delimited by a comma from my remote side, my remote application, and performs data manipulation to get it all from basically a flattened string into its proper data type before it gets sent back to the GUI itself. And then I want to show how the actual send and do VIs look. So if we look at it using the GUI, the only thing that exists here is the message class itself used by Actor Framework, and the function here that's called just the enqueue VI using the queued message handler built in once the actor core gets, or not the actor core, when the actor itself gets launched using launch root actor VI or launch nested actor VI. As an additional point that normally doesn't get made depending on what you're using for this message, I'm wanting to actually send data with the message that I'm using called resource data. And so I'm embedding it using bundle into the actual message type class itself. If you don't have anything special going along with it, it's just sending a message, doing nothing else. This part here would just be deleted. It wouldn't show up here. And then the do VI itself, all it's doing is grabbing the class you're wanting to actually send this message to, what VI you're actually wanting to run, along with additional data if it so exists in the message. If not, this part would also not exist. And then it just tells it, I want to run this VI, which is the VI I showed previously in my Project Explorer. It just opens up this VI here. If I have multiple child objects or child actors existing, it would give me the option of selecting which one I would actually want to use based off of what actor I would enqueue with this message. But here I don't have any further overrides, so it's just this one VI. The other actor that gets launched locally is this resource monitor here. It has its own messages and overrides. Here what we're initializing is the remote address and the local port for the TCP init that I decide to use. And since it's the local side, it's the actual initializer, not the listener. And it gets embedded into the message stream data for this class itself before I send it to the actor core. The actor core is where you're actually going to launch your endpoint. And then here we also create our user events. If we go to the actor core, it's a similar setup of the main thing that runs is a while loop with an event structure placed inside of it. But the main difference here is using the nested endpoint class and creating a timeout and initializing or informing it what message type we're wanting to use. In which this class wire here is the TCP class that I created previously. For using it in the actual actor framework, if you're wanting to pull it out of the class itself or out of the tools itself, what you need is this function here, that's nested endpoint VI. All it does is create this constant that we see here. And then it's following functions right under here. If we wanted to use what's called a notifying nested endpoint, which uses notifiers, it's a similar aspect here, but instead we use this constant class value instead of the regular network endpoint class. And my core here for the events, we just send events, or we send messages to either the network, the other side of the network, or back to the GUI actor, since this is the calling actor of what I'm looking at here. We'll send either messages back up to my caller, or I'll send messages across the network in order to perform the actual data that needs to happen on the other side of the network. In which that endpoint is over here on what I've called the RT resource tool, run target resource tool. Its main application here is creating the same nested endpoint, but here I've created to where it has no timeout for the sake of this project, where it's just endlessly waiting for a connection to the initiator, and also endlessly wait for a message to be sent across. Here, the only event that will actually go on is getting the user event for resource data, in which we will send the message to my my actor saying, I need to obtain the data. I need to actually perform the function. Which that's the main thing here, which I really want to show off because I really liked how it worked. This function here, I'm using a command prompt with a bunch of new commands I got to teach myself for grabbing certain information on your computer and then filters for it. Here, what's happening is 3 commands are being sent. I want the name of my machine, of whatever the remote machine is. I want to know what its current CPU load percentage is. And then I want to get what memory is currently available, what total memory exists on the machine, and in that order. And then I will perform a function that will allow me to create a percentage of that later on the GUI side on the local side of my application. If you wanted to get just the bare bones percentage itself, you can do that using PowerShell. But if I were to do that, in my recommendation, I would have used like a Python script. But I was wanting to keep it to where it's just purely LabVIEW and command prompt for the sake of this project. Then I also grab the current date and time in seconds and set it up in the format that I wish. And I flatten it into one string, and that gets sent across the network. These messages here. When that data gets updated, it doesn't go here, it goes to forgot to put it in this VI. Once all that's flattened to a string, I put it into my user event of resource data to trigger the message to be sent back across the network to its network pair. Once that message gets sent back to the network pair, which is manager, it will trigger this event here on this side that I refer to as flatten response. and queues a message that goes to the GUI class saying, I have new data sent back from the remote target. I need you to parse it and update it to the front panel. And that's eventually what we will see in the local GUI's actor core. It'll update it as the last update from the remote time in the format of day and time seconds, along with the format of month, day, year, the machine name at the top. I grab the total memory from the system in megabytes along with the free memory, and I'll perform a simple division to actually give it as a percentage, along with the CPU load percentage. Then anytime I want a new update, I just have to hit my refresh boolean here. Then I can stop the local actors using the stop button here. And then in action, it looks something like this, where my goal is I would have the remote side always running unless some critical failure were to happen on the remote target, where I would have to restart the machine and relaunch this program. But this should always be running to where once my local machine, I get back to my local machine to create the initiated part of it. We should be fully connected. Here I could have created what's called a endpoint connected override. It's something that's only used in the network endpoint actor package in that library. I've seen it used in the example project LabVIEW provides with you once you install the package, or say you want a boolean to turn green when something's connected. I didn't do this here, but in a future goal, I'm going to have multiple targets that can be launched that it can access, and it would create like a boolean array of actual targets being connected. Here. Ooh, that's not good. I know. An issue I have here is due to slightly poor programming on my part. I have made it in my pre-launch init the IP address I've had to hard code because I haven't created how I want to do my actual official configuration data for multiple targets. So I need to correct it to what it's supposed to be now. So,
Hide right there.
I think that hide was the just block.
Can you go back and reshare your screen so people on screen see?
Okay.
And that pops up to say hi next time, because now I don't have the presentation.
Okay. Yes.
You say hi next there, so stop sharing.
Since you're on the second machine, can you just use the 1.0.0.127 or local host?
I should be able to do local hosts, yeah. But if this was done with something I wanted to do is actually create a virtual machine and have the virtual machine be the remote application. Here, that would be the IP address of that VM instead of localhost. The issue that happened there, I guess I should explain instead of not saying anything. As I talked about, I didn't do proper coding practice of keeping the code separated. That is an issue I have created for myself, unfortunately, where if I stop this remote launcher without it actually letting it connect to something, it creates an error that allows it to lock itself or lock the class itself. However, now we should be able to properly connect. If I hit refresh now, command prompt runs in the background, or runs, and once it closes, I get the data sent back over from my machine. And we can see its accuracy by running the actual task manager itself in Windows. So right now it looks like we're about 12%, a little bit under 10% CPU, and around 40% memory. If I ask it to refresh now, it shows us at a little bit around 15% for CPU. And our memory is still relatively high, but that's probably based on when the actual command prompt is running. If I can clear myself some space here so we can see it actually running the full length. Memory is actually a little off. That's something I'll need to do testing on. As the main machine I did my development on, it was showing the correct results of memory. But this machine wasn't the one I did my development on, and it's actually, the resources aren't as great as on my main desktop machine. So I'll need to do some troubleshooting on that, and also further development to make it be more device agnostic. That's the main functionality of what happens here. And then whenever I want to close it on the local side, or close both sides, it's just the stop booleans I have in place here. Come on. That's what the little bit of my project does using the network endpoints. I know the explanation was brief, but does anyone have any questions about what I showed?
So did you say you can have multiple endpoints? Like you can have one endpoint broadcasting multiple message?
Yes. Yeah. With the network endpoints, you would only have one that would be like an initiator.
Say if we're using TCP, only one would use the TCP initialize, but you can have as many as you want to be like a TCP listener, I believe. But basically, like how we're using it in the application we have at work, we can send in a command that says, hey, I want this time update for all the computers. We send that one message, and all the points along that, or all the network endpoints that share, will get that message.
Very good. Thank you. Appreciate the presentation this morning. And so again, on October 22nd, I'm here at the Aerospace Hockey Center. And it will be part of the roadshow day. So the entire day will be this 10 o'clock to 3 o'clock, if I remember right.
We'll set up a flyer, and I'll have you distribute.
Okay, thanks.
With all the details and the agenda.
Okay, and this group will be a part of that. But in general, November, December, on, this room typically will be the third Wednesday of the month at noon. And I do encourage you to make use of these guys. They have some hardware locally that you don't have to go and order it off the internet. And they allow us to use this room for free, which is really, really nice. And Rich, I wanted to ask you a couple of questions.
Okay.
If you can come up here.
Oh, boy.
So the intent is for you guys to have an
How
opportunity to get.
difficult are that? We need Jared up there to answer.
Okay. So my understanding is that some of you guys interface with Jared already. So this is your opportunity to just say, hi, I am the guy on the other end of the phone that you communicate with. So come on up here. Jared lives in Orlando, and he will be, as I said again, up here next month for the road show. And Rich hails from what part of New York?
Upstate New York, north of Albany, 2 hours north of Albany.
This guy has spent his whole career working for one company, and he liked it so well that he left it to come to NI.
I did the same things.
Oh, did you? Okay.
I was called Aerospace for 26 years, and I just wanted to try something different. So
The neat thing about that is that he knows what we experience. So he's not coming in fresh out of college and trying to figure things out. He has a lot of experience and he's trying to figure things out with you. So anyway, I wanted you guys to have the opportunity to spend some time with these guys. So please have at it, and more pizza, cupcakes, and oh, one other thing. Yeah, Kelsey. Kelsey is marketing, so she's kind of behind, I think, is what it is, and she's not like an upfront person. One other thing, if you have an active certification for a CLD, CLA, CLED, meetings like this give you points toward recertification by points. The way that has to happen means you have to sign up in the back. Sign up in the back, give us your email. You'll get an email that says you came to the meeting, that you can then send out to all the people on that email, kind of the procedure that you use to request points for this meeting. Anything else, gentlemen?
I highly recommend those certifications. It's,
Yes, they're
helps you
very
prepare, helps you learn all the nuances of what you're dealing with in LabVIEW or whatever certification you're getting. And of course, it's a resume builder as well. So highly recommend taking it. And then you only have to take the test once as long as you keep coming.
Very good.
Jerry, you want to talk a little bit about your background?
Yeah, sure. So, I've always been in Orlando. I was born and raised there. So before I worked at NI, which I just got hired at NI last October, so I'm just coming up on a year here as a field application engineer. My former career was as a test engineer at Lockheed Martin. This is a fire control in Orlando. So I used NI's products all the time. Kind of what I worked on the most was automated test equipment, especially automated software. So LabVIEW Test Stand. I don't know if you guys are familiar with Test Stand. And then just kind of writing a lot of TPSs and debugging and troubleshooting TPSs was kind of like my role for about 14 years. And then I got to know my local field application engineers. Spent a couple years just talking to them a bunch. Like we golfed a few times, and then they had an opportunity, and I was like, "Yeah, that sounds good." And so now I work for NI. So it's been working out. But I do have a ton of experience in test and measurement, specifically like automation. So if you guys need if you just have any ideas you want to bounce off of, feel free to let me know. I love trying to solve problems. So.
And outside of these user groups, each company, if you want to reach out and say, hey, I want to do a lunch and I have some people that are interested in this topic, I can go there, I can present that, or I can get Jared up here to help present with hardware, whatever it is you're looking for that you're interested in. Any topic that's NI related, that we can bring in external people. We can have people do that remotely. So, during your lunchtime, outside of this group, if you want to meet more frequently and have that kind of interaction in your company, just reach out.
Any questions? Very good. Please get to know them a little bit here. Thank you guys very much.